So let's start the basic concepts of Hadoop. So basically Hadoop is a tool that is a solution for a problem, and the name of the problem is big data. So there is a problem in the market named big data, and that is a problem for basically SQL, because SQL is all about centralized storage. Means in SQL data must be present in the centralized repository. Let's say currently we have 10 terabytes of data, so we need a server with 10 terabytes of storage. In future data amount will increase to 30 terabytes, then we need to purchase bigger server. And this is a problem with SQL. That's why any of the SQL related database, data warehouse, any of the storage works on the same concept, that is centralized storage. So every time we have to upgrade the server, every time we have to purchase a bigger server. And the second problem is not only storage, processing also centralized. Just like whenever you want to process the data, in that case, you have to submit the query to the centralized SQL engine. And when data amount increases, when let's say we keep on increasing amount of storage, then let's say there is a server that can process, currently that is processing 10 terabytes of data, that holds 10 terabytes of data. Now we increase the data amount to 15 terabytes, then 20, 25, 30, 35. So after a threshold point, performance comes into picture. And then server takes too long to process your query. So same problem Google was facing several years back, almost 15 years back. I can say more than that. So when Google came in the market, before Google there were several search engines in the market like Yahoo, Reddit. But when Google came, then now Google is leading in the market. And I can say Hadoop is a child technology of the Google technology. So Google started a new concept of a distributed storage and a distributed file system, that is storage. And for processing also they are using the distributed environment. So Google, in short, I can say, is using the concept of distributed storage and distributed processing. So this is the basic theme behind Hadoop. So Google started working on a distributed storage and distributed processing environment, and they implemented a new architecture in the market to divide the amount of data in several machines. Instead of purchasing one server with 10 terabytes of storage, why not we purchase 10 server with 1 terabyte in each? And whenever we add a new machine, let's say one desktop is a machine, one CPU, or I can say one motherboard is a machine. So motherboard consists of hard disk, RAM and processor. So if I say a motherboard consists of hard disk, RAM and processor. So whenever we add a new motherboard, we get, let's say, 1 TB additional storage. And not only this, let's say in each machine we have 32 GB RAM, and let's say we have a 4-core processor. So whenever we add a new machine, we are not just adding the machine, we are adding RAM and processor that can help us for the data processing. So this is the concept behind Hadoop. Let's say we have 10 machines. So each machine not only has just storage, that has RAM and the processor that helps in the data processing. So distributed storage based on multiple machine with the hard disk, and each machine not only has hard disk, it has processing related resources, that is RAM and processor. So this is the concept of Google, and the same concept Yahoo employees used. One of them, you have met, duck cutting.
Yeah.
So he implemented a new tool in the market and then named it as Hadoop. So Hadoop is basically just opposite to SQL. SQL is all about centralized, Hadoop is all about distributed. And now in short I told you, let's say you have one bigger room, and that I say search a key, and you have just one table and search a key. So definitely you will instantly give me the key from the table. So same thing, instead of storing data in 20 terabytes, 50 terabytes, 100 terabyte server, why don't we keep multiple small systems with just 1 TB, 500 GB hard disk? And then wherever data is present, we can directly go there and we can use the same system's RAM and processor to run the job. For example, this is not actual architecture of Hadoop. Just let's say there is one system in any of the SQL based storage, and there is 20 TB data stored. So this is a system. Let's say its name is system 1. So there is storage 20 TB available. Then for processing, this 20 TB data is based on one SQL engine, centralized SQL engine. If I increase the data amount to 30 terabytes, then 40 terabytes, then 50 terabytes, then after a threshold point, queries will take too long to process. So instead of one machine, let's say for 50 terabytes of data, why don't we take 50 machines? Better? Means now this 50 terabytes of data we distributed among 50 machines, and each machine contains hard disk that contains this data and RAM plus processor that can process the data. So to divide the workload of one machine into multiple machines is the basic architecture of, I can say, Hadoop. Fine. So now you know something about Hadoop, that Hadoop is based on distributed storage and distributed processing. Now let's take another example. If I say Windows 7, Windows 8, Windows 10 or Oracle or any other software, so that is based on some services, correct? That is based on some components. Just like operating system is based on file management system, input output channel management system, drivers, any of the database, any of the SQL based database is based on two components, storage and the processing engine, how to store data and how to retrieve data. Similar to any of the database or any of the data warehouse, Hadoop works based on two components, how to store data. So for data storage there is a file system for Hadoop named Hadoop Distributed File System. Means Hadoop is based on distributed environment, just like I gave you example, load of one system, why don't we distribute on multiple machines? So Hadoop is based on distributed environment, and Hadoop save data as files. And this term made Hadoop storage flexible. A file can store any type of data. For example, it can store structured data, example, any of the relational database, any of the data warehouse, means tabular data, or wherever you have structure defined, or it can store semi-structured data, for example, XML, HTML, your server logs, fine, your emails. For example, in HTML, XML tags are fixed, but data type can change. In emails, number of fields are fixed, but you can directly send a text email, or you can attach any PDF, you can attach any Excel. So the type of data is not predefined, and almost 90% data nowadays we are generating online, and that is all about semi-structured data. So XML is a file, HTML is a file, logs file, emails we can export as file, and the third and the last type of data is unstructured data, that also we are generating nowadays in huge amount, just like on Facebook, Twitter, WhatsApp, any other application, real-time application. Let's say you want to purchase anything on Amazon, on Flipkart, So there they display images as well. So unstructured data means binary data. That covers images, audio and video. So binary data is unstructured data. So any kind of data, see, you can save any image, any audio, any movie, any video as a file. You can save this data as file. You can export any of the database or data warehouse tabular data as a file. So Hadoop made storage flexible. That is the reason, let's say if you want to save any image or any audio or any HTML, XML file, so in any of the SQL based storage. So first you will convert the data in the relational format, correct? But in HDFS you can directly dump data. So that's why in HDFS write operation is faster than SQL. Because in SQL, if data is structured, that's okay, we can directly load. But if data is semi-structured, unstructured, then first we have to pre-process data to convert unstructured or semi-structured data into structured. Then only we save in HDFS. Fine? So that's why this is again advantage in HDFS Hadoop, that storage is faster than write operations are faster than SQL. Fine? Now processing engine is basically a framework. So Hadoop is based on framework for data processing, and there are two frameworks named MapReduce and Yarn. So MapReduce is a framework for data processing. Now MapReduce is replaced by Yarn. There are several reasons. Yarn means yet another negotiator. Just like SQL is based on SQL engine for the data processing, and Hadoop is based on either MapReduce or Yarn. So basically, now you know for storage there is HDFS, and for processing either we can use MapReduce or we can use Yarn. Now Hadoop has three major releases. Hadoop release 0.x.y. X.y means 0.0.1, 0.2.0, 0.20.2, like that. Then release 1 came in the market, means 1.0.0, 1.2.1, x and y can be any integer values. And then the last and the final one is Hadoop release 2. So the latest release available in the market nowadays is 2.7.1. Even 2.7.2 also came. So x and y can be any integer value, and you can get the list of all of the releases of Hadoop. So if you install earlier releases, that is that is release 0, release 1, then you will get HDFS as storage with MapReduce framework for the data processing. So if you download release 0, release 1, then you will get this package, HDFS with MapReduce. And if you install release 2, then you will get HDFS with Yarn framework. So in release 2, in the latest one, MapReduce replaced by Yarn. So there are major changes at processing level, and at storage level, that is HDFS, there are minor changes that we will discuss. Got it? Yes. So this is the basics of architecture of Hadoop, and before going into any details, let me tell you about HDFS and MapReduce. Then we will discuss about Yarn. For example, HDFS is based on some services. So Hadoop is based on HDFS, MapReduce, or HDFS Yarn. Either HDFS with MapReduce framework or HDFS with Yarn. Now HDFS is again based on some services. Just like I told you, any of the software is based on some services. So HDFS specific services are name node, secondary name node, and the last one is data node. MapReduce framework is based on two services named job tracker and the task tracker. And now that is replaced by Yarn. Yarn is basically based on 4 services but there are two major named resource manager, and the last one is node manager. So if you install Hadoop release 0, release 1, then you will get this. And if you install Hadoop release 2, then you will get this with this. Fine. Now, the next concept is about, as you know, Hadoop is based on distributed environment, means we have multiple machines. So types of machines, and a machine is named as a node in Hadoop. Fine. And there can be multiple machines in a Hadoop environment. So there is one more term in Hadoop named cluster. So cluster means a set of
collection of
nodes, means a set of machines. So in Hadoop, a set of nodes is a cluster. In real time, we work on a multi-node cluster of Hadoop. Multi-node cluster means in which we have several machines. And there are two types of machines named master and slave. So in real time cluster you will find limited masters and there can be large number of slaves. So these masters basically control all of the slaves. And slaves are the actual workers and masters are the controllers. Okay? So this is just very basics about Hadoop, and now we can discuss about little complex or little in depth about Hadoop. So let's start with this. There are two types of machines in Hadoop. So in master, out of these many services, so forget about yarn now. Let's talk about release 0, release 1, HDFS with MapReduce. So in master, out of 3 services of HDFS, we run 2 services, name node and secondary name node. And in slave, we basically run only one service named data node. So that's how we distribute out of these 3 services, 2 services in master, which are the controllers, and data node and slave. About MapReduce, a particular service named job tracker we run in master, and the task tracker we run in slave. Now why we have these many services? So let's talk about this. Name node contains metadata, means data we store in files, because HDFS is a file system. So let's say you have stored 2000 files or 200,000 files, let's say, in the cluster. Now which particular file is present in which particular slave, in which particular node, in which particular machine, out of several machines. Let's say we have total 500 machines. Out of 500 machines, in which particular node a particular file is present. From where you will get this information? From the metadata storage, that is name node. So name node basically handles where is a particular stored in the cluster. Are you getting it?
yes, sir.
Let's say if name node failed, then entire metadata gone. That's why for name node there is a backup named secondary name node. So this is backup of name node. Now data node you can understand is the actual worker that runs in the slave. It's data storage. So basically we store data in data nodes. So job tracker, now job tracker handles the life cycle of the job, means life cycle management of job. So the job life cycle management is the responsibility of the job tracker, and the last one is task tracker. So the task execution is the responsibility of task tracker. So let's say whenever you submit any job for read, write or data processing option to the job tracker, then it assigns a job ID, create a job, then resource allocation means RAM, processor, then wait for the job completion, then collect the output, deallocate all of the resources and submit the final output is the responsibility of the job tracker. And the logic that you write in the job, who executes that? Basically task tracker. So for example, job tracker is a manager and task trackers are developers. So manager assign the task, then developers do that. So this is the reason we have 5 services, and an individual service does what? Now you know.
Okay.
So I'm giving an example of a multi-node cluster of Hadoop. So now you know which service run in which particular machine, and basically we run name node, secondary name node and job tracker in separate masters, because if we run within same machine, let's say name node and secondary name node are running in the same machine, if name node gone, if that machine gone, then name node, secondary name node both gone.
Both of them are.
That's why these must be there in separate machines.
Yes.
And even job tracker also be run in a separate machine, so that individual machine has its own resources. And if we share the resources between name node, job tracker or secondary name node, job tracker, then we have to share the RAM, hard disk, processor, and we will get the slow performance. So that's why it's better allocate a separate master machine for name node. I am typing NN. Allocate a separate master machine, means master node, to secondary name node. So these two machines contains their own RAM, processor and hard disk, and assign the third master machine to job tracker. Means there are 3 nodes, there are 3 machines. Now we don't split data node and task tracker. There is some reason. And where we run data node and task tracker in slave machine. So let's say there is a slave, its name is slave 1, and slave DN means data node, and TT means, let's say, task tracker. So there is a slave named slave 1, and which we are running data node and task tracker. Now there is one more slave named slave 2, and which again data node and task tracker. And let's say there is one more slave named slave 3, on which we are running again data node and task tracker. So 3 masters, 3 slaves. There can be more than 3 slaves. Let's take example of 5 slaves. So each slave machine contains one instance of data node and one instance of task tracker. So once we will be done with this, we'll start Yarn, that is the latest release of Hadoop. So why we have data node and task tracker together? Let's say you want to process a file and that is present in slave 2. Then no need to call, let's say if task tracker is running only in slave 1. Then data is in slave 2 or slave 4, slave 5 that you want to process. Then first we need to copy data from these slaves into slave 1, then we can start processing. That's why wherever data is present in data node, because you know data node is responsible for data storage and task tracker for task execution. So basically we store data in data nodes. Let's say each slave machine has 1 TB hard disk, then we can store up to 5 terabytes of data, because where we store data only in data nodes, not in the name node or secondary name node. So we have 5 terabytes of storage, and wherever data is present there are task trackers. So all these slaves task trackers are controlled by job tracker, and all these slaves data nodes are controlled by name node, and the backup of the name node is there in secondary name node. The backup of the data also there, name replication factor, that we will cover later. But all these data nodes controlled by name node, backup of the name node in secondary name node, and all these task trackers are controlled by job tracker. So it's a 5 slaves, 3 masters, 8 nodes cluster of Hadoop, and we can say it's a multi-node Hadoop cluster. So there are total 8 nodes. Now let's say after 5 terabytes of storage we need 2 additional terabytes of storage, then we can add 2 more slaves with 1 TB each with hard disk as 1 TB in each slave. Correct?
Correct.
So it's just example of a Hadoop cluster.
Okay. But the master size will be fixed. The masters will be fixed.
Yes,
But we have
limited masters, and they can be, yes, we don't require the fourth master now in Hadoop release 0, release 1.
Okay.
And there it is, Hadoop, let's say virtual cluster. This is a virtual cluster image of Hadoop. Let's say this. And now you will be able to understand. Just like it's a multi-node Hadoop cluster, there is a master for name node, there is a master for job tracker, and there is a master for secondary name node. These three. And in each slave machine there is DN plus TT, means data node plus task tracker. And we can club multiple machines within a rack. So basically Hadoop cluster is a collection of racks, and each rack is a collection of nodes. It's a multi-node Hadoop cluster. There is a Hadoop cluster. In the cluster there are multiple racks, and in each rack they can be either master or slaves. That's it.